Okay, this is lecture 12, and we will learn the point-slope formula, which is just a different way of doing exactly what we did in lecture 11, using y equals mx plus b, finding the equation of the line. And we will also do linear modeling, and that you can think kind of that in a different way. For lecture 11 and for the first part of 12, I throw you different pieces of information, and you have to find the equation of the line. That information might be a slope and a point, it might be 2 points, it might be a point and a relationship to another line, all kinds of information. For the modeling, basically I'm going to throw you a story, and from the story you need to get the equation of the line. The easy ones will already have the equation for you. The medium ones there will be 2 points that you can kind of find in there, and the third ones will be a little bit harder to see, but they're still not hard. So before we go any further, I just want to go back and look at a problem from lecture 11. We're going to do the problem the lecture 11 way, and then I will introduce the point-slope formula, and then we will do the same problem the point-slope formula way. So, first of all, here's our review problem. So, to find the equation of the line, the first thing we always do is find the slope. So if we know the slope is -2 and the line passes through 1, -5, first step is to find m. M is given, so that's easy. I've got my slope. Now I know that the line passes through the point 1, -5, so I need to find b, and the way I do that is to use y equals mx plus b. I put the slope I just found, that -2, I put it in place of m, and in place of x and y, I put my 1 and -5 respectively. So I'd have -5 equals -2 for the slope times 1 for the x. Simplify, I get -5 equals -2 plus b, add 2 to both sides, and I get b equals -3. So that gives me an equation of y equals -2x minus 3. And remember, the graphs on your homework are there to check your work. They are not there to do the problem. You have to do the problem using the formulas, but you can use the graphs to check your work. So let's graph y equals -2x minus 3. What's the first thing I put on my graph? Do I look at the slope or do I look at the y-intercept? Okay, the first thing I put on is the y-intercept, which is -3 right there. And then a slope of -2 is going to go down 2 over 1 or up 2 back 1. So there's my up 2 back 1. Down 2 over 1, slope of -2. So let's make sure that this matches the information written in black. The slope is -2. Now we might not be able to look at that and say, yes, that's a slope of -2, but we can say that's a negative slope because it's a decreasing line. As you move from left to right, the line is going down, so I know that slope is negative. So at least the slope is -2. It looks like it could be a slope of -2. Now, does the line pass through the point 1, -5? Well, let's look at it. Start at the origin, go over 1, down 5. Yep, that line goes right through that point. So it looks like that's my right answer. Okay, that's the old way of doing it. Here is the new way that we'll learn today. Okay, these are the steps that we did last lecture. That's what we just did in the last example. Now, if I use the point-slope formula, you'll notice I've got a new little formula right there. And the steps when I use that formula are my first step is to find the slope. So no matter what information you're given, and no matter what method you're using, method 1 or method 2, you always find the slope first. After you find your slope, now instead of going through 2 steps, finding b and then writing down the equation, we'll do it all in one step. We find the equation all together. So let's look at an example. Well, first of all, I want to show you where that formula comes from. Does this right here look familiar? The y2 minus y1 over x2 minus x1 equals slope. It should look very familiar. Now what's different about the way I've written it? Okay, I've written it with m coming at the end. Instead of m equals, it says equals m. Now I've done that for a reason, but it's the same thing, right? I mean, it looks a little different, but it's exactly the same thing as what you've been using before. Now, if I wanted to clear fractions, I'd have to multiply both sides by the denominator. That would give me y2 minus y1 equals the slope times x2 minus x1. Now, what does that subscript mean? Why do I have y2s and y1s and x2s and x1s? Okay, remember when we're using that slope formula, my y2 was my second y value, my y1 was my first y value, my x2 was my second x value, my x1 was my first x value. Those were all just little placeholders for the numbers I was going to plug in. So what I want to do is I want to keep the x1 and the y1. I'm still going to plug in numbers there, but instead of a y2, I just want a plain old y. I want it to remain a variable. So I drop off the y2 and I'm just making it a y. And I drop off the x2, I just make it an x. It's better if you're handwriting that to just make it really bold like this. So my y is just a y. He's a variable. He will stay a variable. y1, on the other hand, is going to have something plugged in for it. My x is just an x. That is a variable. But my x1 will have something plugged in for it. Now, the pros and cons of using this method might be a little hard to understand before we do an example, but let's just kind of list them quickly. First of all, the point-slope formula is not a form. It's a formula. It's a tool. So you cannot leave your answer in that y minus y1 form. You've got to either put it in standard form or in slope-intercept form. All of my examples I'll put in slope-intercept form because I think it's a lot more useful. The pro to using this slope-intercept formula is that it's slightly shorter. We only have 2 steps instead of 3 steps. The con is it's one more thing that you have got to remember. Okay, now let's use it on the next example. So there it is at the top of the page. There are my steps. First thing, find the slope. Second thing, plug everything into the equation and simplify. So my slope is -2. My line passes through the point 1, -5. Again, this is exactly the same problem as before. We're just going to do it using method 2 instead of method 1. So my first step is to find the slope, and it's listed. So that's easy. My slope is -2. Okay, the next thing I do is I plug everything in. My y, that bold y, stays a y, but my y1, I'm going to put -5 in place of y1. My slope, I'm going to put -2 in place of my slope. My x, the bold x, remains an x, but instead of x1, I'm going to put in 1. So I'll use my formula, and I have y, that's the y that stays, minus y1, that's the y from my point, equals the slope, which is -2, times x, that's the x that stays, minus x1, that's the one that comes from my point. Now I can't leave it like this, I've got to simplify. So I'd have y plus 5. Be careful with your negatives, it's easy to drop them sometimes. But y minus a -5 is y plus 5. Now I distribute that -2, so -2 times x is -2x. -2 times -1 is +2. Again, I can't leave it in this form. I've got to either get it in standard form, which has x and y on one side and the number on the other, or slope-intercept form, which is what I recommend. So we'll subtract 5 from both sides, and I get y equals -2x minus 3. It's exactly the same answer that we got the first time we did the problem, which is good, and we can check it exactly the same way. Remember, the graph is there to check your work. It's not there to get the answer. So there's my intercept. There's my slope of -2. And just like before, that is a slope of -2, and it goes through the point 1, -5. So that is how we use the point-slope formula. And the next couple of segments of the videos will just be lots and lots of examples using that formula.